Hi, I'm Scott and we are Teammate, and for our Plastics Reuse project, we redesigned the injection plunger. So for ours, we moved for three main goals. One is obviously safety, accessibility, and then simplicity. So for safety, our biggest priority was making sure that it wasn't going to move or cause harm unexpectedly. And the biggest threats were both it falling, if it was raised up and caught on something, it would just move unexpectedly because this is rather heavy and that could be a serious hazard. Or if you're operating this device and you're not familiar with it, you can cause harm by overpressurizing the plastic. And we'll get to that in a second. But first, for stopping for falls, so once you're done with the device, you just put this pin in place here. As you can see, it will stop it. And that is super important because now when you're using this, it's going to be safer and you're not going to know where it is at all times. And you can raise it up to do maintenance and you don't have to worry about holding it up there. And now if you're moving on to operating the device and you're not really familiar, you're not going to have a whole lot of understanding of how the implanter will work. And that's actually kind of dangerous because if you overpressurize the plastic by pushing too hard or going past when the mold's full, it can shoot out hot plastic that can cause serious harm. So our way to prevent this is making sure this lever has a visual design. And that means as you're operating the lever, you can physically see when you're getting close to emptying the syringe, and that is when you would expect to start getting resistance and stopping using the lever. Now this is better than sometimes crank designs, because crank designs, you have no visual way of determining when you're full, and that can be a serious hazard because now you can push past it and shoot hot plastic all over you. And then moving on to accessibility. One of the biggest features of our accessibility is we can adjust leverage here and height here, and we also have a foot pedal for people who have a little bit less strength and would like some more control. So if we'll get to each of those individually, so for the leverage, you can just pull out these two pins, you can slide it along, and I can show you right here, you just slide two pins back in, and you have more leverage. And now, when you're adjusting height, all you have to do is just pull this handle out, and in the final design, this will be two threaded handle, so that'll be even easier. And now here you just slide it in, and now you're suitable for someone a little bit taller. And if you also need more control or additional strength, you can use your body weight with this foot pedal here, and you just stick your foot in, and you can pull it down. And that way you can be hands-free and get a lot more control. And then our final aspect of our design is simplicity, because this is going to be run by students who are probably not super familiar with the injection molder framework and design, and that can be an issue because you're going to have to troubleshoot this device as it goes through wear and tear. So one is we only have a single moving part, which pivots up and down like this. And that is really nice because there's only one part to troubleshoot if something's going wrong. And additionally, we have the same fastener for all of this so that you can only need to buy one fastener if you need to fix something that's broke or damaged. And our last part of it is we don't change any of the design language already provided to us so that this will work with whatever all the other components from other team members have come up with. So this has been our presentation on the injection plunger design. Thank you.